in this video, we're going to talk about equivalent ratios and reducing ratios. So make sure that you have a pen and that you're ready. So we're going to say that by the end of this notes, I can find equivalent ratios. All right, and with our ratios, last time we talked about the value of the ratio. So when you write it as a fraction and then reduce it. So ratios are equivalent when they have the same value. So when you reduce the ratios and get the same thing, or when they are equal when reduced. Okay, so you're going to reduce both of them as much as you can, and if they equal the same thing, they're equivalent. Equivalent is just kind of a fancy math word for equals. Okay, so the steps for that is that you're going to divide each side of the ratio by the same number until you can't divide anymore. And guys, that's pretty much it, okay? So if you get stuck, start with this list. So see if 2 works, see if 3 works, 4, 5, 7, and then you can kind of go on that way, okay? That's not like the end-all be-all list. Other ones to try would be 9, 10, 11, 13. So you can add those to your list if you would like. Okay? So the instructions here say circle all the equivalent ratios in each box. Sorry. Okay? So I'm going to go through and reduce them as much as I can. And then if they reduce to the same thing, then they're equivalent. Okay? So the ratio 4 to 5, can't reduce that anything. There's nothing else I can divide them by. The ratio 7 to 8, I can't reduce that anymore. 144 to 180, I can probably reduce that one. Okay? So I'm going to grab my calculator. And I'm going to start with 2. Okay, so this is what I think through every time I do these. So I'm going to start with 2. So I'm going to do 144 divided by 2 and 180 divided by 2. Those were both divisible by 2. That's the word I'm looking for, divisible. Oh my goodness. So I'm going to write that I divided this side by 2. And I divided this side by 2. Let's zoom in a little bit, help you out there. Okay. So when I divided by 2, 144 divided by 2 is 72. Then 180 divided by 2 is 90. So my next step of the reduced ratio is 72 to 90. Okay. And then I'm seeing that these are both divisible by 9. Okay. So, zoom back out for a second. 72 divided by 9 is 8. And 90 divided by 9 is 10. So 8 to 10, and then I see that that is divisible by 2 again. And 8 divided by 2 is 4, 10 divided by 2 is 5. Okay. Do I see any that look the same as this? Yes. 4 to 5 and 144 to 180 reduces to 4 to 5. Those match, so I'm going to circle them. Okay, then I'm going to try this one. So I know that 56 is Actually, I'm going to show you this way, okay? So if I don't know, I'm not seeing anything right away, I'm going to try my method. Okay, so I'm going to start with 56 divided by 2. Okay, 75 divided by 2. 75 is not evenly divisible by 2, so 2 doesn't work. Let's try 3. 56 divided by 3. Ooh, not evenly divisible. It has to end up with a whole number. Okay, it can't have a decimal. 3 didn't work. Let's try 4. 56 divided by 4. Ooh, that's a whole number. And then 75 divided by 4. Not a whole number. Okay. So there are no common factors. I can't divide these two by anything, both of them, and get a whole number. So that one's not going to be equivalent. Okay. Let's try this one. The ratio 0 to 2. Can't divide that anymore. 1 to 3. I can't divide those anymore. 1 to 1. Okay, what do you notice about these two? About 1 to 1 and 2.5 to 2.5. Do you notice how they both have the same number on either side? So I could divide this by itself, divided by 2.5, and get the ratio 1 to 1. So if you ever see a ratio where both sides have the same number, like 1s or 2.5s, those are going to be equivalent. Okay. All right, the ratio 1 to 2, there's nothing else I can divide 1 by, so that's already reduced. Same thing with 2 to 3. I can't divide it by anything else. Okay. 14 to 21. Let's try our method again. I know that 21 is not divisible by 2 because it's not even. Okay, so 4 also doesn't work, 5 doesn't work, 6, but 7. Are both 14 and 21 divisible by 7? Yes, so I'm going to divide them both by 7. Okay, 14 divided by 7 is 2. 21 divided by 7 is 3. And then I stop there. Okay. All right, 16 to 24. What can you divide both 16 and 24 by? They're both even, so they're divisible by 2. 2 is always a great place to start. Okay, 16 divided by 2 is 8. It's a funny 8. 24 divided by 2 is 12. Ooh, I see that 8 and 12 are both divisible by 4. So I'm going to divide by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. Okay. So these three, when reduced, all get the same thing. So they're all equivalent. Okay. So like equivalent is like equals, but their initial form, right, where we started, doesn't look the same, but when you reduce them, you get the same. All right, last one, 120 to 140. If it ends in a 0, it is divisible by 10. So we're going to divide by 10. 120 divided by 10 is 12. 2. 140 divided by 10 is 14. Okay. Then I see that these are divisible by 2. 12 divided by 2 is 6. 14 divided by 2 is 7. Okay. 13 is not divisible by anything, so this one's already reduced as much as it's going to get. All right, and then 216 to 252. I kind of am feeling like it's divisible by 4, so I'm just going to try it. Okay, 216 was divisible by 4. 252 is divisible by 4, so I'm going to do 4. 216 divided by 4, it was 54, compared to 254. 52 divided by 4, it was 63. Okay. Now it looks kind of tricky, but I know that 54 can be divided by 9, and so can 63. So I'm going to divide by 9. 54 divided by 9 is 6. 63 divided by 9 is 7. Don't be afraid to use your calculator, okay? For whatever reason, I always have to double check 54 divided by 9. Just for whatever reason, my brain does not compute. All right, so now this one's reduced all the way. So I see, oh, and their reduced forms, A, C, and D, all match when they're reduced. So those ones are equivalent. And guys, that's it, okay? So if you get stuck, try starting with one of these numbers, go through the list, see if it works. And then on the back, you're just going to reduce levels 1 and level 2. Then on level 3, you're going to find the matching equivalent ones. You got this. Have fun.